Warm greetings to one and all present here. Let me introduce about myself. My name is Mr. A. Jasmine Anthony Raj, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. Today, we are going to see about the lecture series on the topic compound analysis from the subject data science. So here, if you want to move with an topic, so first let me give the explanations for the compound analysis in data science. It is nothing but it is used to refer a set of statistical and machine learning techniques. So we can able to have different types of machine learning techniques. So we can able to learn one by one. So what is the purpose of using this learning techniques means? So we can able to reduce the dimensionality of data by transferring the original variables into a smaller number into a new variables called as a component. So here already we have a set of informations where we can able to transform those informations of an original variables into a smaller number of new variables. So this is this concept is called as a components. So which we can able to preserve in much of the important information. So here if we are having an variance or instructions, wherever it is possible we can able to do this process. Next one, so it is especially useful for when we are dealing with an high dimensionality data. So here if we cannot able to use this and for all the data, here this component analysis will be used only for the high dimensional data. So here multicollinearity and noise topic that aligns closely with the concepts like curves of dimensionality. So here we can able to use only for the purpose of using a concepts like curves of dimensionalities, which we can able to have to exploring. So next one, let us see about so why this component analysis is needed. So what is the purpose of using this component analysis means? So in real world we can able to use the use in the data science problems. So here if you want to know about so data sets, it may have to be defined as hundreds or thousands of features are there in the data science. So next one, if you have to consider about what is the features of this concept means, it is highly correlated one is the features. So here if we can able to check with that high dimensionality means, so where we can able to define this high dimensionality means it can able to leads to increased computational cost. Next one, overfitting and poor model generalizations. So these are the informations where we can able to have a leads to an high dimensionality leadings. Next one, component analysis can able to help by reducing the dimensions by using then component analysis. So analysis means getting an accurate results or checking on what is the process going on. So where if you are doing this component analysis, we can able to have reducing dimensions. Next one, we can able to remove the redundancies. Repetitions can be able to be removed. Next one, we can able to have an improving model performance and interoperability. Interpretability. Next one, key objectives of an component analysis. So what are the keys which may involve in this component analysis? So first one, we can able to have a dimensionality reductions, feature extractions, noise reductions, data visualizations. In data visualizations we can able to have a 2D and 3D. Next one, we can able to have a handling multicollinearity. So here these are the key components which is available in a component analysis. Next one, let us see about types of component analysis techniques. So what are the different types of component analytic techniques which are available? So under that first one, principal component analysis. That one is called as PCA. PCA means the most widely used component analysis technique. So here apart from the available techniques, we can able to use this component as PCA is being used mostly widely used component analysis technique. So what is the concept of this means? So we can able to transform the original variables into an uncorrelated principal components. So why? Because means so each component can capture a maximum variance. So here original values variables can be able to converted into a non-correlated principle. So why? Because we are doing means so because of having each components can maybe capture a maximum variance. So that is the reasons. Next one, let us see about key characteristics. So what is meant by key characteristics means we can able to transform the key characteristics means we can able to have a components or orthogonal independent. So next one, we can able to have a first component capture highest variance. Next one, sensitivity to scale, that requires an normalization. Next one, let us see about what are the applications. So here first we can able to use for the image compressions, gen expressions and analysis and then visualizations of an high dimensional data. So here if you want to see about an first one, that is an independent and component analysis, that is an ICA. The concept is we can able to find the component that are an statistically independent, focuses on a non-Gaussianity and a non-variance. So here this is the concept of a independent component analysis. Next one, we can able to see the key characteristics. So it is useful for an signal separations, and it can also be used for the concept that is the component are an independent, not just an uncorrelated. So this is the key characteristics. Next one, we can able to see with the applications, that is an audio signal separations, that is a cocktail party problem, and EEG and then brain signal analysis. So here we can able to use this in PCA for this type of an application. Next one, factor analysis. So what is meant by factor analysis means the concept is given as a model observed variables or linear combinations of an intent factors. Next also it can able to focus on an explaining and covariance, not an total variance. So we can able to have to check only a part of the totaling, summing of sum of the variables, not with the total variables variance. So next one, what is its and key characteristics means we can able to have a included an error terms. So what are the errors which may occur and what is the reason, so that we can able to give in this and factor analysis, and we can able to check with that used more in a social sciences. So that is a field where it can be able to in a more number of an important terms. Next one, application psychological testing. Next one, survey data analysis. Next we can able to see with that singular value decompositions. The in short form we can able to call as an SVD. So it is the concept is called as an matrix factorizations technique. Next one, we can able to forms the mathematical foundations of an PCA. So these are the concepts. So next one, we can able to see the key characteristics, that is works directly on a data matrices used for sparse and large data sets. So these are the key characteristics. Next one, we can able to see the applications. Applications means we can able to recommender systems we can able to use with this concept. Next one, we can able to have a text mining and an LSA. LSA is a short form for a latent semantic analysis. Next one, linear discriminant analysis, that is in short form we can able to call as an LDA. So supervised component analysis. So what is the concept of this means we can able to maximizes and class separatability. Components are chosen to best discriminate between and classes. What are its applications means we can able to use for an face recognition, medical diagnosis and an classification problems. So let us check with the next let us see with the next topic, and component analysis versus an feature selections. So here component means we can able to have an different divisions. So first one, we can able to see the aspects, component analysis, and then what is the feature selection. First one, an output. So output means it is considered as a component analysis for a new component. In feature selections we can able to have a subset of a original features. Next one, interoperability, lower, higher. Next one, and correlations handling. Here we can able to have an excellent for an component analysis. For feature selections it may have only a limited process. So next one, an use case. So it is an high dimensional data domain driven models. Next one, so steps in an component analysis using an PCA examples. So here by using this component analysis, what are the steps we need to follow? First one, we can able to can collect and data collections. Next one, data cleaning. Next one, standardization. Next one, covariance and matrix and computation. Next one, elegant values and an Elen vector calculations. And next one, and component selections. And last one is a data transformation. So these are the steps which is available in a component analysis. Next one, let us see here what are the advantages. So it can able to reduce the data complexity, improves an algorithm speed, reduce and overfittings, and help and visualize complex data. So here reducing and complexity means, so by using these implementations we can able to have a clear idea of a data, so without having any of the confusions. Next one, it can able to give the improving the algorithm speedily we can able to use them, which type of algorithm will be shoot. So next one, we can able to reduce, so overfitting cannot be able to occurs, and very often it can be reduced, and finally it can able to visualize the complex data, which data is used for making a complex informations. Thank you one and all for giving me this golden opportunity. Let's meet in another session.